Hello everyone, my name is Vivek and today I'm going to make a presentation on HTTP. So let's see what all we have in today's agenda. We'll see the overview in which I'll talk about the HTTP definition, the history of HTTP, the difference between HTTP 1.1 version 1.0, why we are taking this, we'll talk about that while talking that particular slide. Then we'll talk about HTTP messages that has request messages and response messages. Then we will see what methods and status codes are, what all different kind of headers are involved, the general headers, request response headers. And then we will talk about caching, cookies, and a little bit about pipelining. So let's start with the overview. So HTTP was invented by Tim Berners-Lee. It's a networking protocol, foundation of data communication of www. The current version is HTTP 2.0, but we are not going to talk about that in this particular slide or this presentation. So it functions as a request and response protocol. Until the request is not received, the response is not given. The default port of HTTP on a typical server is port 80. So it's not mandatory to have port 80, but it's configurable. The underlying protocol is TCP. Why? We'll see in one of the slides. So as we said, it's a request response flow protocol. It's an application layer protocol. The basic function is that when a client initiates a request, then gets a response. Now, how the request is initiated? The very first request is sent is a TCP message. First, the TCP three-way handshake is complete, and then only HTTP message is being sent. So when client request is initiated, the HTTP client sends a request message formatted according to the rules of the HTTP standard or RFC. An HTTP request, it's called. This message specifies the resource that the client wishes to retrieve or includes information to be provided to the server. Then server gets this request and it responds back. The server sends, the server reads and interprets the request. It takes action relevant to the request and creates an HTTP response message. Typically, these are HTML pages or the requested objects, which it sends back to the client. The response message indicates whether the request was successful and may also contain the resource that the client requested if appropriate. If there is an error, then also the HTTP server responds with the error code. We'll see the error code in detail. So as we spoke, the underlying protocol is TCP three-way handshake. Now, what is this? And why TCP? The very first question. Why not UDP? So TCP is chosen over UDP because of the various reasons. Few are very obvious, like it's more reliable protocol. It's request until and unless the acknowledgement is not received or it validates the message was not delivered to the receiver, it tries to continue to send the request. If a response is not received or acknowledgement is not received, that means the message was lost and HTTP try to correct it. Then why TCP is chosen over UDP is also one of the reason is that UDP is directionless protocol. Its UDP is important or is used typically on scenarios where like a video conferencing is happening, live video, where even if few frames are lost, not much is impacted. Video streaming, right? But where if the data packet loses out of a chunk, a major chunk, or if you're trying to download a file, if one packet is lost, the file may get corrupted. That's why TCP is chosen over UDP. If you want to read more about TCP and UDP, always Google the differences between TCP and UDP. You'll find so many. Now we'll see what TCP three-way handshake is. So when client initiates a connection to the server, it sends a SYN package that is synchronized and it will also send a sequence number. Now, when the server receives this message, it sends the acknowledgement for this request, and also the number is incremented by 1. Now client will know, oh, this is the acknowledgement for the message that I sent earlier having sequence number 1000. So it knows my message was received by the server, and this is why it's acknowledging back. Now even server wants to know whether the acknowledgement that I sent was successfully received at the client or not. So it's also sends a SYN packet similar to the very first request that client sent with a sequence number. And then finally the client responds with an acknowledgement to this particular SYN packet with incrementing a value by 1. So the very first side of the communication was ensured that it's getting delivered from client to server. In second part, the messages from server to client was sent and acknowledged back. So the server knows my messages are getting received by client successfully. So this way, the client and server ensures that the channel is working properly and it's further good for further communications. Now the session is established. Now, right now we have HTTP 2.0. Before that we had HTTP 1.1. But even before 1.1, there was HTTP 1.0 and 0.9. So in today's agenda, we are seeing the differences between HTTP 1.1 and 1.0. Why? Because this was a major change and it was a game changer for entire internet. In 1.1, multiple host names were supported. This resulted in the concept of virtual hosting. Till 1.0, on one IP, only one site was possible to be hosted. Since 1.1 started supporting multiple host names, even on one IP, multiple websites were possible to host. So this ensured that a lot of IPs were saved. Otherwise, we would have ran out of IPv4 addresses long back. Now, HTTP 1.1 support persistent connection by default. So what does that mean? So in 1.0, when the connection is established between client and a server responds back, then that TCP channel or TCP connection is stopped. Again, while making second request, the TCP three-way handshake is initiated. So this was an overhead. Because of that, once the connection is established, again, the three-way handshake will happen. Then because of the sliding window protocol, there would be a slow start. So initially the data sent from one side to another will be slow, then gradually it increases. So because of these overheads, it was slow. So to solve this problem, HTTP 1.1 had by default persistent connection support. How it happens is that when client initiates a connection to the server, it gets a response back. Now even after getting the response, it's the connection is not broken. The pipe is still intact, so that if needed, further communication can be used or can be done on the same pipe. So this way, we are removing the overhead of three-way handshake and slow start problem, right? So this made HTTP 1.1 faster. So there are a few headers which are involved that we call connection keep alive. That says, okay, keep the connection alive. And if server sends connection closed, that means it's saying that, okay, connection can be closed. Now, if the connection is remain intact for a longer period of time, it might end up eating up all the persistent connection capabilities of the server. All the threads will be occupied. So after a certain amount of time, the connection is torn. This we call a timeout, that is idle timeout. By default, typically I have seen servers is idle timeout of 300 seconds. Now in HTTP 1.1, it was possible to send byte range request. Now what is that byte range request? So suppose you are trying to download a file. You don't download entire chunk at one go. So you slowly starts to download from beginning and then it gradually it increases from byte to byte. So In typically, if you see the use case of a download manager, it breaks file into multiple parts and starts downloading those files in parallel. So if there are restrictions of per TCP connection, speed limit is there, you bypass that, making multiple TCP connection. In the use case where you are watching a YouTube video or any other video, and you want to move the seek bar or the pointer, you want to skip certain part, and you suppose there's a video of 5 minutes, you just want to skip first 2 minutes and start after that, you move the seek bar. Now what happens, that window, or that the sliding window, translate that movement into a byte range request and then sends a fresh request from the minute 2 to the server, saying that okay, I need the file not from beginning but from this particular point onwards. So these are the use cases of byte range request. If server supports byte range request, these advantages are there. Now next we are going to talk about caching and proxy support. We will be discussing caching in detail in one of the slides, but as of now I'll just tell you that in 1.1 there came the support of caching and proxy. Now HTTP 1.1 started supporting more methods. In 1.0 there are only few HTTP methods are there. In HTTP 1.1 there came the options method. There are a few other methods also that came in 1.1. Now, as we spoke in earlier session or earlier slide, that HTTP 1.1 allows HTTP client and a server to set up a persistent connection. The TCP connection is kept open after each request response set, so that the next request and response can be exchanged immediately without waiting for the TCP three-way handshake to happen. The session is only closed when the client is done requesting all the document it needs. So in this way, suppose we are downloading a page or you are requesting for an HTML page, you get the response with that HTML page. Now that HTML page has multiple embedded content to which the browser initiates the request. Now in a scenario where TCP connection is closed, again you end up requesting for a new TCP connection, and then on for each and every embedded object it does the same. So there are a lot of overheads which was removed using this persistent connection. That same scenario is shown here when a client, this left hand side is example for HTTP 1.0, where client makes a request, gets a response, connection is closed. Again, some time lag is shown here between close and open, that is for TCP handshake. Again, request goes, response comes, and then wait time. This was solved here because the connection was once established, it's not closed. The request came to the server, response came to the client. Then again, the new request is initiated by the client, and then next response was received. It goes on. So you are saving a lot of time. So this improves efficiency. It reduces server load because of removal of TCP three-way handshake. And it also helped in pipelining. We have a slide on pipelining that we will be talking about. So don't worry for now. Now, let's go to HTTP messages. Now there are two kind of messages, request messages and response messages. So the messages are defined as per the RFC, because you need to follow a certain set of rules. Because if I'm talking to you in one language and you don't understand that language, then the communication will not happen. So there is a set of rules defined, that is what the protocol does, and because of that we adhere to a message formats. So all communication takes place via HTTP messages, request, responses. It's a text-based message. Now the format is, the very first would be start line, then there would be message headers, then there would be a blank line, then message body. We'll see that. So start line conveys the nature of the message. Header name, header value separated by colon is the format for headers. Then there would be carriage return line feed character, what we call CRLF character, CRLF. Then there would be message body if it's present. Now let's see how it looks like. We have the request line. First, the first character says get. That is the HTTP method. So it says get this particular object or resource slash doc slash test.html. Then HTTP 1.1. This is the version of HTTP being used. When the server receives this, it knows what version is supported by client. Now the next line, it's start with HTTP message headers. These are all request headers. So host is mandatory in HTTP 1.1. It was not there in 1.0. Host is www.test101.com. Then accept image GIF, image JPG. So it says what all things I is accepted. What language I support? The browser says I support EN US. Then what compression mechanism I support? I support gzip and deflate. Now who am I? This is what user agent says. So this browser is Mozilla 4.0. In case of iPhone, it will have iPhone in it. In case of Android, it will have Android in it. So this is how a browser reveals this information to the server that this is the particular browser I'm running this operating system, version of operating system is this, and my version number is this. This is how the client knows, okay, who is requesting for the object. You might have seen, like from mobile, if you request for a page, it looks different, and from desktop, it looks different. Now, this is how the server identifies who is requesting for that object. Is it a desktop user using Mozilla 4.0, Mozilla 8.0? I don't know what number Mozilla is going to right now, just an example. Or iPhone 7 is requesting for this object. So accordingly, the page is modified or adjusted and delivered to the end user. Now, what's the content length? If it's a post request, content length is mandatory. In GET, it's not. A blank line separates the header and body, and then the request message body. If it's GET method, you may or may not have the body. Now let's come to the response messages format. Similar to request line, it also has a status line, then response headers, then a carriage return line with character or an empty line, and then starts the body. So first line says, okay, we are working on HTTP 1.1. 200 is the response code and it's its human readable interpretation, that is okay. Cool. So we'll talking about status code in detail in one of the slides. Don't worry right now. Now next line onwards, there are response message headers or response headers. So it has like date, what is the current date of the server, what server it's responding, what was the last time modified time of that object, what is the entity tag, e tag, accept ranges, byte, what is the content length of the response. Connection, it says you can close it, and the content type is text plus HTML. Now you may need to know few headers. These are few headers I have mentioned here, but I'll talk about some more headers. Then there is the blank character, the blank line, and then starts the body. So this segregates the header section and the body section, this blank line. That's why it's important. So I told like we'll be talking about more headers. Few headers you should know is last modified. That says what was the last modified time of that object on the server. All right. Then host header we already spoke about. User agent is a request header. Another header which is important is if modified since, IMS header what we call. So what's the beauty of it is that it helps in caching. We'll talk about these headers in details when we are talking about caching. Similarly, there is an e tag header which also help in caching the object. We'll also talk about this. Now next we are going to talk about methods and status codes. So what all different HTTP methods are there? There are various methods like get, head, post, put, options, delete, trace. So it's basically a series of commands for the client to prompt the server to take action. It's always, always, always in upper caps or upper letters. The common type of HTTP methods used is get, head, and post. Request that server receive the resource specified by the URL. This is done by the get. If the URL is correct, server will send back the appropriate response to the client. The request cannot be processed properly, then An error message may be resulted. That is, suppose 403, 404. We'll talk about it in detail when we are talking about status codes. Now, head, it's similar to get, but it tells the server not to send the actual body, just the headers part. It is used by the client to check the existence, status, or size of a file before deciding whether to go forward or not. Now, suppose you are trying to download an object, you requested for that, and your data limit is 2 GB. But when you get the object, it's actually 10 GB in size. So you initiate a head request, which tells you the object size is 10 GB. This is pretty useful in case of download managers or when we are playing a video. The video player accordingly translates and makes the sliding bar appropriately. Then there is a post request. This allows the client to send an entity containing arbitrary data to the server for processing. It also enables the client to submit information such as an interactive HTML form to a program on the server. Now, even GET can be used for sending data from client to the server, like POST. But there are few differences. In GET, if you're sending the data, it has to be in the URL. So we use query string parameters for sending the data. Now, suppose you're sending a username and password. So you requested for www.server.com/login.html, then question mark user is equal to username and password is equal to password. Plus, if there are any other data you want to send, you keep adding ampersand character and then a name value pair is sent in query string parameter. Now there is a limitation on the length of the URL. Thus, there is a limitation on the amount of data you can send using get method. While in post, the the requested or the message or the data is being sent in request body, which has no limitation on the data size. Hence, the data limitation is not there in post, but it's there in the get. Another difference would be if there are caching server in between, the get requests and responses are cached, but post it won't be. Another difference might be if there are intermediaries, proxy or your ISP is having a proxy server, there would be a log lines generated. Those log lines logs the requested URL. So if you're sending sensitive data in GET, that is easily available to anyone who is going through the log lines. While in POST, the data is sent in the body, which is not logged. Hence, it's little bit safe. I cannot use the word safe, but I'll still use safe in quotes because it's not for common person. He won't be digging through much. But again, if you are sniffing the traffic, you can always see what exactly the data is being sent in, even in post body. So these are the limitations. We'll see what all different limitations are there in one of the slides, but let's move ahead. Another methods which are common is options, put, update, delete, trace. Now, few methods are called safe method because for obvious reasons. But suppose if you're using delete method, you can delete any resource on the server. It's dangerous. Or put, you can put any malicious file on the server. So it's not safe, right? That's the reason it's not. And I'll also quickly talk what options method does. So options tells what all different HTTP methods are supported on the server. If server is not enabled to listen for a particular HTTP method, it will respond saying that method not implemented. If I remember correctly, the status code is 405. Then put is for putting the object on the server. Now, difference between post and put would be for post, there should be a programmer or program handler for handling those data which is being posted to the server. But while put, it's just place the object on the server. Update is used for updating the existing object on the server. Delete, as the name suggests, it's for deleting the file. Trace is for analysis of what all hops was taken from in the network while data was being sent from this point to that point. Now, response codes, there is a status code we saw, right? 200. What are these? So HTTP status lines contain both the numeric status code and a text or human representable interpretation of the status number. Now 200 here is the status code. The reason it says OK. So there are five categories of status code: 1XX or 1YY, 2YY, 3YY, 4YY, and 5YY. So one is informational messages like continue. If there is a slow connection, it's sending data. Still some more data needs to be sent. It will says okay, continue. We'll continue to send some more data. 2YY or 2XX represents success criteria like 200. That means it is successful. It's okay. It's going good. Now 3YY is redirectional. Suppose if you are requesting for an object and that object is not present on the server, but it's moved somewhere else, it responds with a redirection message. Either 3001 that is moved permanently or 302 that is moved temporarily. Now what's the difference between 301 and 302? So if the object is moved permanently, that means it's not coming back. That means even the caching server or the uh, search engines can cache this data, and the location which comes in 301 can be cached. While 302, it's temporarily moved. Suppose a mobile user is requesting for a www site. The site may respond with, okay, you are a mobile user. Get redirected to m dot whatever site it is. Suppose it's www.google.com gets redirected to m.google.com. That will be a temporary redirect because it's only given to that particular user because it's using a mobile device, right? Now 4xx. 4xx and 5xx are error category. But while 4xx is resulted by the action of client, 5xx is resulted by the action of server. One example would be, suppose you are requesting for an object and that object is not found on the server, it says 404 that is not found. Now, this action was initiated by client by sending an incorrect URL of that object which is not present. That's why it's 4xx or client error. Suppose if the server receives the request but it's unable to fulfill it, the gateways was timed out or bad server, some different kind of error happened on the server, so it responds with 5YY error code or 5XX error code. You can read more about different kind of status codes. They are everywhere. You can go and read wiki page, you can read RFCs, and you can know many other status code which are useful. One of the status codes which is very useful is 304, that is not modified. We'll talk about it because it helps in caching. So that we will discussing while talking about caching. Now next section we are going to talk about headers. These are the request and response headers. We already spoke little bit about it, but we'll see what all different headers are present. It's used in request messages. It allows client to provide information about itself to the server. It also gives details about the nature of the request. It also allows the client to have greater control over how its request is processed and how or even if a response is returned by the server. Few examples of request headers are accept encoding, accept language, authorization, expect, host, if match, if none match, if modified, sends, if range, max forwards, proxy authentication, and on. Now, a few response headers we'll talk about. It appears only in HTTP responses. It provides additional data that expands upon the summary of information that is present in the status line at the beginning of each server reply. Examples are accept ranges, age header, e-tag header, location header. So when a server responds with redirection 301, 302, it also tells which URL you should request for this object which is moved now. So that value is present in location header. Now another header which is server, which tells the client, okay, what server am I? Am I Apache? Am I IIS server? Or am I Nginx? Vary header, www authenticate. It tells the user that authentication is required and please send the username and password. It pops up with the username password box on the browser. Now we'll speak about few important features like caching, cookies, and pipelining. So very first topic is HTTP caching. It's The definition of caching would be the storing of recently requested resource in a temporary area on the server, or for temporary storing the object so that if next time that object comes, it's delivered from the cache itself. What are the different advantages of using caching? So it reduces the bandwidth use by eliminating unneeded transfer through request and responses and faster response time for the user loading a resource. It can be implemented at various places, client, intermediary, proxy server, even on web server. So this is an HTTP client. Suppose if there is no caching, every time the request will initiated by the client, it goes all the way to server, hits the server, gets the response back. There is a time lag every time the server is getting hit. Suppose a big event happens and everybody starts to access this particular same server. It get overwhelmed. It gets so many requests that it's not able to process it, and it's become a denial of service. That is DOS situation. So to solve this problem, there are caching servers. Typically, they are called content delivery network server or even proxy servers. They will cache those requested object. So next time if this request comes for the same object on the server, it won't go forward. It will deliver from its cache itself. Thus, it will save these much time that is used for sending the request from the server to the from proxy server to the origin server and getting the response back. Plus, it also saves the bandwidth of the server plus the resources, other resources like persistent connection or RAM plus bandwidth. So these are the various advantages. Now, caching can be implemented at browser. Browser also caches so that if a logo is suppose it's cached for Google, next time if you're requesting for that, it won't request for that object. It will take it from browser cache and will show it on the browser. It can be done at proxy levels also, or CDN servers. Typically, they does the same thing. They are just caching servers. They cache that object and delivers to the request for end users. Same caching can also be implemented as HTTP server so that the actual application server is getting less number of hits. Varnish is one example which is implemented on this HTTP server, which is used for reducing load. Memcache, these are all server-side caching softwares. So when caching happens, how the caching server knows or the proxy server knows or the end user's browser knows that the object which I have cached is still good to go. It's not stale yet. So there are various factors which helps in deciding whether the object is still good to be used or not. One of the identifiers that comes with the object is with the help of headers, that is last modified and then some particular value with date and timestamp, or it comes as e tag, entity tag. So when client gets the object, it knows when was that object was last modified and what's the entity tag associated, or when what's the entity tag associated with that object is. So next time the client tries to validate it, so it sends the request. If there is a last modified value associated with it, it sends the request saying that if modified since and the value contains the same one which comes in last modified value. So if the object was last time modified on 1st January 1 a.m. in the morning, the client will send the request saying that if modified since 1st of January 2017 and 1 a.m. The proxy server gets the request, or the server gets the request and says whether the object is good or not. How? Now, if the object is still good, they will respond with 304, that is not modified status code. If the object is modified, then a 200 response code will come, and with that 200 response, the new object will be delivered. So, if modified since header is useful in terms of validating the object. Similarly, for entity tag, e tag header comes in the response, and to validate it, if none match header is used. Now, how long this object should be cached? One another factor that comes in response header, that is cache control header. So it will have cache control header and max age. So max age says how long the object should be cached. So till that TTL, or time to live, whatever value that max age contains, the object is still good to be served. So the end user will cache that object or the proxy servers will cache the object for that particular amount of time. So cache control, max age, and some value. If cache control has no store or bypass cache, no store means don't cache it. Bypass cache means this time don't get or don't fetch the object from the cache, just bypass it. Use this object this time, but don't remove the object from your cache. Keep it in the cache. That's how it works. Now next we are talking about cookies. So HTTP is a stateless protocol. The server doesn't know whether this is the same client which was requesting previously for this resource. So to identify, to establish a session or to know who is requesting, cookies are used. There are a few other methods which can be used, but cookie is one of them, and we are talking about it now. So cookie is used in few contexts to refer a small piece of significant data. It's a plain text file which is stored on your on a client machine. How it's transferred from one place to another? It's done using cookie header. So when the first time a user is requesting for an object, server can send a cookie to the client in a header called cookie, set cookie. So set cookie means set the cookie, and then it will have a name value pair. It may also have for what domain it's applicable, for what path it's applicable, and when it's going to expire. Now, next time onwards, a user is requesting for the object, it sends the cookie along with the request. It will send a cookie header and then the same name value pair what is received in set cookie value. This is the reason when you once log into your Facebook or Google account, you don't need to type username and password with each and every request. You just type once and the cookie is set at your browser, and then server identifies it's the same user and it validates and then it serves the requested content. When a server implements a function that requires states to be maintained across the set of transactions, it sends a small amount of data to the web client called cookie. It contains important information relevant to the particular web application. So cookie is very important. About pipelining. So using HTTP persistent connection, the shortcomings of slowness was solved, or the shortcomings of HTTP 1.0 slowness problem was solved. Now to further accelerate the process, the concept of pipelining came into the picture. So in a normal scenario, what happens? The client's request for an object, it gets the response back. On the same TCP connection, next request is initiated. It waits for the response to come back. Again, when the response is received by the client, it again sends the request to the server, wait for the response to come back. Now we see that a lot of time is wasted here because we are waiting for the response to come back. How about we solve this problem by sending multiple requests one after another without waiting the response back? So this is what the pipelining does. In the same TCP connection, multiple requests packet are sent without waiting for the response. And then when the response comes, it's all the response received by the client, the connection is closed. So in this pictorial representation, you can see how much time is being saved, right? So this is the advantage of pipelining. There are a few limitations of HTTP. It's less secure because the data is transferred in plain text. Anyone can do man in the middle attack, can listen to the traffic, and can read what exactly is being transferred from one place to another. It's unencrypted. Thus, man in the middle attack is possible. Data can be tampered, one can change the data and send it forward. Thus, it's less reliable. To solve these problems, HTTPS came into the picture. So HTTPS is not in today's agenda, but we'll talk about it in one of the sessions later. So as of now, remember what all HTTP concepts you learned today. If possible, read more about it on various articles. And if you have further questions, feel free to ask in the comment. Thank you so much guys for watching this.